In this R code tutorial, we'll explore the ideas of recipes and workflows in a tidy models framework. Let's frame this in what we've been doing thus far. Thus far this semester, we've been doing a two-step process to build linear regression models using the tidy models package. In step 1, we specified the structure of the model that we want to build. So far, we've been focusing on linear regression models. In the regression setting, that is, when our response variable y is quantitative, and we've been using the LM function or engine to actually build or estimate these linear regression models. So in step 1, if we specify the structure of our model, it's in step 2 that we estimate this model. So we take our model specification, here labeled LM spec, and we estimate or fit it with our data and to a specific relationship. Here, I want to model y by two predictors, x1 and x2. Great. But we're at the point of the semester where we need to expand this process. Mainly, our modeling algorithms are going to get more complicated than the least squares algorithm. At least one of the following might be true, which we haven't had to worry about thus far. So it might be true for future algorithms that we have to pre-process our variables or data before running them through the modeling algorithm. For example, we might have to standardize or scale our variables before feeding them into the algorithm. Again, we haven't had to do that thus far. Another thing might happen in the future. Mainly, our modeling algorithm might require that we run through the modeling process multiple times. For example, our algorithm might have one or more tuning parameters. And to pick a good parameter, we must estimate or build the model using a range of possible parameter values and then choose among these. Again, the idea here is just that we have to run this process multiple times, once per each possible tuning parameter. Again, we haven't had to do that for least squares algorithm. We just run it one time. It doesn't have any tuning parameter to worry about. This means that we need a new workflow. So in this R code tutorial, we're going to explore a new workflow that allows us to do those two things. It allows us to pre-process our data and run a variety of models without reinventing our code each time. So let's think about these ideas through an example. Though our new tidy models process with recipes and workflows isn't necessary for building linear regression models, we're going to start by exploring it in this familiar setting. First, as usual, we'll load the packages that we'll need for our task, mainly tidy models and tidyverse. And then we'll load the data that we'll be using in our analysis. In this tutorial, we'll be using some built-in data on black cherry trees. If we just check out the head of that data set to give you a sense of what we're looking at, we have information, each row represents a tree, and we have information about its diameter, its height, and its volume. And specifically in this tutorial, we're going to be focused on the relationship between volume, measured in cubic feet, and tree diameter, measured in inches. And we're going to want to build a linear regression model of volume by tree diameter. Mainly, if I can measure the diameter of a tree, which is much easier, how can I use that to predict the volume, which is much more difficult to measure? Now, to build this linear regression model of tree volume by diameter, we're going to start our tidy models process as usual. In step 1, we're going to specify the structure or the general modeling algorithm that we plan to use in our analysis. Now, nothing here in step 1 has changed. We have the same exact code in this example that we had before. We want to build a linear regression model in a regression setting using our LM function or engine. And when we check out what's stored in LM spec here, it's just that same exact information that we just give it. Now, one thing to note, and we've noted before, is that nowhere in this code do we specify anything about the variables of interest or the data that we plan to use in our model. We've just set up the structure of our model. So in step 1 of our process, we specify the structure of our model, and in our new step 2, we specify our recipe. So if you think about the word recipe, we'd probably think about cooking. Say maybe I'm making a batch of cookies. Now in a cookie recipe, that word recipe includes information about our ingredients and how to prepare them. The idea of a recipe in tidy models is the same. Mainly, that recipe is going to have to indicate what are our ingredients for the model. Or in the modeling setting, ingredients are the variables in our relationship of interest. The recipe also needs to have information about how we're going to prepare our ingredients. That is, how will we pre-process our variables before feeding them into our algorithm. And finally, our recipe needs to indicate basically where to find the ingredients. So what data set contains information on our variables? So putting that all together in our second step, we're going to specify our recipe, which indicates what variables we want to use in our relationship of interest. If necessary, we're going to prepare or pre-process those ingredients or variables, and we're going to specify where to find those ingredients or variables. Now, though pre-processing is going to come into play when we talk about more advanced algorithms, for the least squares algorithm, we don't yet have to pre-process our variables. So we'll explore that idea in later tutorials. For now, let's consider a simple recipe with no pre-processing. So I'm going to store my data recipe as data recipe. And the way that I build a recipe in the tidy models framework is with the function recipe. And again, in the recipe, I need to indicate my ingredients or variables. So here, I want to model volume by diameter. And I also need to indicate where to find those ingredients. So what's the name of my data set? Here, the name of the data set is trees. So again, this is my data recipe. It indicates what's my y variable, what are my predictors, or in general, what are my ingredients and where to find them. So if I run this chunk, I set up my recipe, and I can check it out. Now, this recipe is pretty boring, right? I didn't do much. I basically just took some ingredients and threw them into a pot. I didn't have to pre-process or prepare them in any way. So what my recipe output tells me here is basically just that I have one outcome variable or response variable and one predictor. Great. Now notice here that the code in our variable recipe, it focuses on the variables. It did not specify anything about the algorithm that we'll use to explore those variables. So we'll bring these pieces together in step 3. Step 3 is our workflow creation. It brings together the model structure and our variable recipe. And once I know what my model structure is, and I know how to work with my ingredients, then I can set up my workflow. So the way that the model workflow works is I start with the function workflow. That just simply communicates I'm about to tell you the workflow that I want to follow every time I run through an algorithm. Again, that workflow consists of two pieces. First, I want to add my recipe to the workflow, or indicate how to work with my variables. And recall that we stored that information in the data recipe. In my workflow, again, the data recipe only tells me about the ingredients or the variables in my analysis. It doesn't tell me what kind of algorithm or model to build. And so then I want to add my model to my workflow. And we stored that in lm spec. So my workflow consists of my data recipe and my model structure. And I can run this code and then check out the workflow. So again, not much has happened yet. The workflow is just specifying or reiterating what I've told it. I want to build a linear regression model. In my recipe, which includes possibly pre-processing variables, I didn't pre-process any variables. I just gave it some variables. So it's telling me it doesn't have any kind of pre-processing steps because we didn't tell it to do anything. And then it tells me what our model is. So again, the workflow is combining the information from my data recipe, which I didn't give it much information there, and what type of model we want to build. Now notice here that we haven't yet estimated or built the model. We've only specified the workflow for doing so. So this is kind of like opening a cookbook and you can read through a series of steps, but that doesn't mean that you've actually made anything yet. All right, so that happens in step 4. So step 4 is model estimation. That is where we estimate or fit our model using our specified workflow. Now in the past, our model estimation has started with our model structure. But here, we're going to start it with our workflow, which we stored as model workflow. Again, that just tells me the structure of my model and the variable recipe. It doesn't tell me to actually build it. So to actually go through this workflow and build that model, I use the familiar fit function. The last and only piece of information that I need to give this function is what data to use in this analysis. All right, so I can write or run my model. It applies the workflow or runs through that workflow using my trees data. Now notice that, again, I didn't have to do what we've done before, which is do lm spec and then fit and then specify the relationship volume versus diameter using the trees data, because that information is already included in the workflow. lm spec is specified in the workflow, so I don't need that information. And we also know that the workflow includes the recipe of volume by diameter. All right, and that's it. Now that we've built our model, which I should run, we can proceed as usual. My model is now in the familiar format. I can look at the tidy summary table. I can get the r squared using the glance function. And at this point, everything is the same and we can proceed as usual. So in summary, an expanded tidy models process has 4 important components. First, we need to specify the model structure or what algorithm we want to run, for example, linear regression. Second, we have to specify a variable recipe. For example, I want to model y versus 2 predictors, x1 and x2. In step 3, I bring the first 2 steps together. I want to combine my model structure with my variables of interest as specified in the recipe. And finally, in step 4, I apply this workflow to my data, and that estimates the model. All right, so we'll get to play around with that more in the future, but those are the big ideas.